Welcome everyone. My name is Faulkner. I'm the Online Event Coordinator for Staff Development for Educators, and I'd like to thank you for joining us today for Identifying and Diagnosing Math Error Patterns, Grades 1 through 5 with Sandra Chen. Before we start, there are a few things you should know to allow for Sandra to be heard clearly. Attendee microphones are muted. Please use the questions box on your screen throughout the webinar to ask questions. We'll use those for our Q&A period at the end. Most audio and video problems you might experience during the presentation can usually be solved by closing any other programs or applications you might have open on your computer. And the session is being recorded, and assuming no technical difficulties, you'll receive a link to the archive within 48 hours. And finally, at the end of today's presentation, you will see a short survey, and by completing that survey, you do assist us in providing future complimentary webinars. Now, for those who might not know us, Staff Development for Educators provides professional development for pre-K through 12 educators through on-site PD, PD events, web-based PD, and PD resources. We empower educators with research-based, innovative, and rigorous PD that's practical, motivating, and fun. We're pleased to have Sandra Chen joining us today. Sandra is an experienced classroom teacher who has worked with both mainstream and special education students. She's utilized multiple grade levels of the Singapore Math program to help advance the mathematical capabilities of her students. Sandra believes that drawing on Gardner's multiple intelligences throughout all content areas encourages students to pursue academics not only in the classroom but outside as well. Her love of teaching shines through in her energetic and enthusiastic presentation style. Welcome, Sandra. Take it away.
Hello everyone, welcome this afternoon. Thank you for joining us. I know it's probably been a long day and here we are jumping right back in, keeping it going. So we are going to be looking this afternoon briefly at identifying and diagnosing math error patterns. A little bit more about me. Math is my passion. It's what I love doing most in the classroom. And so a lot of what I get to do is not only help my own students, but help other teachers when it comes to diagnosing math errors and then figuring out how we can best help our students move past those errors to master those skills. So we're going to skip right past that because we already went through that. And we're going to look a little bit at how we recognize when a concept is misunderstood for a student. Because what is most important is we need to know really what are the sub-skills that are necessary to successfully complete a specific computation. So is the student missing a piece of prior knowledge in order to complete what we're asking them to complete? And that's really important because we can teach and teach and teach, but if they're missing a skill prior, they're going to have a very difficult time understanding the new concept. And then what is the instructional objective? So really we need to look at when we're teaching a student a skill, a math-based skill, what do we want them to get out of that understanding? Do we want them to learn a specific strategy? Do we want them to know why they're doing what they're doing? What really is the purpose of what we're teaching? And so in order for us to figure out where a student is misunderstanding something, we need to make sure ourselves as educators that we're focusing on the instructional objectives that we're looking for in that lesson. Now, error pattern analysis, and this is kind of, where we want to really start to look for why a student might be struggling with a specific skill. First, we need to understand what the child is doing incorrectly. So how do we do that? We can look at the problems that they're solving and see if we can find an error in the calculation. So if we're doing a 2-digit plus 2-digit addition problem, are we having an error in number sense? Decomposing numbers, following the strategy of renaming, or is something else missing? So looking at that, do we not know basic math facts? Do we not understand the concept of 2-digit numbers or 3-digit numbers or what have you? So first we need to figure out what a child is doing incorrectly. And sometimes that's difficult, because you might not see the same pattern over an entire page of problems. So the best way to understand this is to sit down and have them talk you through what they're doing. 4, 5, 6 problems. So we're looking at double-digit addition problems, and we're asking them to explain step by step, what are you doing? And that's how we start to figure out, well, is it that we don't know our math facts, and that's an error where we're going to go back and just work on math facts, or do we not understand the process? Do we not understand the numbers that we're working with, so place value and number sense? And then we need to understand why they're making that error. So what is it that is causing them to make that error? Now, it could be a flaw, and we're going to look at this in a little bit, a flaw in how it was taught previously, and unfortunately that does happen. Is it, they have been doing it incorrectly over and over and over again. No one caught that error, and so they've taught themselves that this is the right way to solve the problem, and then that's something that we need to work on. Or is it just more like a, is it more like they are missing the skill that they were supposed to be asked to solve for? So what we need to look at and understand is that most errors are not careless. So when a student is producing a math problem, solving a math problem, what we know is that they're solving in a specific way because they think that they are doing it correctly. It's meaningful to them. It makes sense to them. So that is where we need to really start, because it's a flaw in their thinking. And errors are based on an extension of a previously known or simpler procedure. So when a student is given, again, a multi-digit addition or subtraction problem, the error is typically based on something that they've worked on prior to that. So just basic two-digit or single-digit addition, 7 plus 8 is 15, and not understanding those facts, and then they're carrying to a much more complicated problem. And so we need to look at why a student has created those errors in their thinking and how we move them past those errors. So here's where we're going to kind of get into the meat of this. Implications of assumptions. So students have been shown the correct procedure many times before and have somehow rejected it. So why have they rejected being shown this procedure the correct time? Now, it could have something to do with a lot of times a memory issue. It could have something to do with a processing issue. And so no matter how many times they're seeing a procedure taught, they're missing a specific step. So remediation needs to discredit the incorrect procedure. And in order to do that, we need to figure out where they're finding or where they're missing that step in the procedure. Remediation needs to provide a sound basis for the student to internalize the new process or strategy. And now, this is probably the hardest part, because when you learn something, you really internalize it. And so how do we get them to kind of shift gears? And we look at this in terms of problem solving, and we'll talk a little bit about this in a minute. But many of us were taught to problem solve using guess and check or working backwards, a variety of strategies. And then as I moved into the Singapore math program and we worked on modeling as our strategy and specific steps, I really needed to internalize that process. Students really needed to internalize that process because it gave us a different way of thinking about problem solving, a higher level process for problem solving. And so when a student is having difficulty rejecting a procedure that's been shown to them many times, we need to go back, find the error in that procedure, and then get them to internalize the new process. So it's going to need to make sense to them. And we know that what works for one child is not going to work for another child. So it's so important that we understand that we cannot just keep teaching the skill the exact same way over and over and over again, because it's not going to necessarily help them get past that flawed thinking or that flawed understanding or misconception. What we need to have them do, or what we need to do as educators, is provide them with a variety of different strategies to solve that problem. So let's say we're looking at this double-digit addition problem, for example. And we want a student who is struggling with the idea of renaming to understand the concept of renaming. Now, we have the problem written vertically, and the student is a very common error we see, 25 plus 38. You have 5 plus 8 is 13, and they just write the 13 down there rather than putting down the 3, regrouping the 10. That 1 represents a 10. Now, we know that as adults and teachers, we've been taught that way, but how have we really been taught that? I know when I was in school, we put down the 3 and we carried the 1. But is that really what that means? And so when a student is having an error like that, for example, we put down the 3, we carry the 1, that has no meaning to them because it's not indicating the correct value. So they may understand the 10's place value column, the 1's place value column, and we look at the number 25 plus 30, or the problem 25 plus 38, and you have 2 10's and 5 1's plus 3 10's and 8 1's. So we understand that breaking it down in a place value chart, but when a student goes to put it into the algorithm, they may not be understanding that concept. So if we just teach them to put down the 3 and carry the 1, and they're just putting down 13 because we say that 5 plus 8 equals 13, we need to go back and work that type of a problem, maybe using a place value chart, using manipulatives, and showing them a variety of ways to make sure that the remediation makes sense to them. We can't just keep working through that algorithm, giving them additional practice over and over and over again, because the algorithm isn't making sense to them. Unless a student's flawed thinking is altered, more practice will not work. So you can give worksheets over and over again, and it's not going to assist in the problem. You know, we look at basic math facts, for example, and so many schools, my school included, does math fact time tests, right? And what is that? That's practice for fluency and for computation knowledge, fact knowledge. But for a student who is lacking in number sense and understanding the basic facts, a fluency test and just giving them math facts over and over and over again is not going to assist them in performing at a higher rate. Now, when students are initially learning those facts, does it hurt? Absolutely not, because you are building fluency. But for a student who's given math facts and just writes down any answer, continuing to give them, we do 64 problems in 3 minutes. 64 problems in 3 minutes, well, you might have 64 wrong answers. And is that really helping them get past their flawed thinking and actually learning this skill? No. So we want to try to move away from the more practice and work on giving them concepts that and procedures that they can actually be hands-on and utilize to get past what that error is. And even with basic math facts, yes, we can look at flashcards, we can look at unifix cubes, place value discs, a variety of manipulatives that you would pull out in a K1, even second grade classroom. And sometimes you need to do that in 4th and 5th grade. Same thing with multiplication and division facts. Number bracelets are fabulous for that, giving a student a hands-on approach to understand and practice the skill that's not just drill, because drill is not always going to work. And just re-explaining that process the same way, like we said, will not work. So, you know, sitting down and just telling them to memorize their math facts, for some students, yes, they'll memorize their math facts, but for other students, and we find this to be very common, memory is the issue. And so no matter how many, copy your facts that you got wrong on this 5 times each, no matter how many times we ask them to do that, that's not necessarily going to help them memorize their facts, because with poor memory skills, recall of those facts is going to be a bigger struggle for them. So remediation, once an error pattern is discovered, what do we do with it, right? So we've talked a little bit about that. So we need to determine if the student has the needed prior skills. So what was the last concept the student understood? This is probably the hardest part because there could also be gaps in between skills that are learned. So let's say we're looking at double-digit multiplication, go to like a 4th grade scale. Well, maybe they understand math facts, right? Maybe they have memorized their multiplication facts, but they have lost mastery or understanding of place value. Because let's be serious, we all teach place value at the beginning of the school year, and we do it every year. We teach it in K, we teach it in 1, we teach it in 2, 3, 4, 5. We continue to teach place value because we're not using place value consistently through the school year. So you get to double-digit multiplication, and a student has lost the concept of place value, the understanding of those numbers. So while they may know their multiplication facts, you may need to skip over that and search a little bit further to more basic skills or concepts, because the flaw is at that point, or the, you don't want to say that they forgot because they haven't used it for a significant period of time. And so you may need to even go back further than you think, because, hey, they're not doing double-digit multiplication, but they know their math facts. Well, there's something missing prior to that. And so that probably, like I said, will take the most time trying to figure out what the last concept the student understood was. Remedial instruction is different from original instruction. And so let's say you're teaching double-digit multiplication using area model, and that's your initial instruction concept. When you go to teach a student who is struggling with this concept, you want to pick another instructional strategy. So maybe you're going to use manipulatives. You may not pull them out as much at the upper grades, but for a student who isn't seeing the visual, you want to go back to the concrete. So for those of you that don't know area model is a visual model to solve double-digit or higher multiplication problems. It is similar to lattice in the sense that you're going to set it up kind of in a box. It is much different than lattice in the sense that you are looking specifically at value of digits, multiplying by value of digits, which assists students who struggle with retention of place value and number sense, because if they're consistently using that place value and number sense, then they don't lose it. And then we don't have this problem where maybe they know their facts, but they have forgotten how to utilize the idea of place value. So if you're teaching using area model initially, you're not going to want to use that concept to remediate. You're going to want to go back to something that might be a little bit more simplistic, using place value discs on a place value map where they can make groups of. Now, yes, that is difficult when you're looking at double-digit multiplication. However, you may have a student that's going to need that. So look at smaller numbers. Look at 10 times 12 versus 25 times 38. And that will help you help them start to build their confidence and understanding. Because when you can show them or use a manipulative to solve multiplication problems, then the goal is to move to that visual model. And then from that model, we move to a more abstract algorithm, or we move to other modes of solving multiplication problems. You want to consider reteaching conceptually as your first option. So like I said, using manipulatives is your best way. Start all the way back at that basic. If you see that you can give them a manipulative, then you want to move to the next strategy that you're going to work on. Algorithm, regardless of need for remediation or not, should be the last thing we teach, because typically an algorithm does not teach why we're doing something. And many times these errors come from not understanding why something works the way it does mathematically. As we said, don't rely only on drills. So drill requires memory, and memory oftentimes is the problem. So we want to look at giving students, again, understanding of the why we're doing something versus just drilling them and having them recall from memory. They need to be able to utilize skills available to them that don't require them to just pull a fact from memory. And remediation should help the student to develop strategic thinking skills. So again, the whole purpose of remediation is to give a tool to assist them really to get to that algorithm and to understand why they're doing what they're doing. So why does, 25 times 38 equal what it does? Why, when I am doing a long division problem, maybe I do partial quotient, or I do long division, or I do short division, why do those problems work the way they work? And so giving them a remediation strategy, something that is more concrete initially to start, typically helps the student develop strategic thinking skills. Okay, so let's look at some interventions. Really, I'm just going to talk through some of these that will assist when you are looking to remediate. Place value charts are key, whether it's addition, subtraction, multiplication, division problems. Many times when you have a student with a flawed thought process, going back to a place value chart, using place value discs, Unifix, cubes, what have you, a smartboard, anything where you can show them a place value chart and how to add, subtract, multiply, or divide on that chart will assist them in correcting the flaw in their thought process, because a lot of times we see the flaw show up in the algorithm. Going back to that very basic helps us get past that flaw. Number bonds. Number bonds are essentially fact families. It's just another way that we look at them specifically in the Singapore math program. Math in Focus uses them as well. And number bonds teach students the bond between three numbers. So if we're looking at 3, 7, 10, students learn the bond that the numbers 3, 7, and 10 go together, so that 3 plus 7 is 10, 7 plus 3 is 10, 10 minus 7 is 3, 10 minus 3 is 7. So they learn them all together, basically learning the fact family together, versus, at least when I was in school, and even some programs now I see it, breaking that apart. So we learn our addition facts, then we learn our subtraction facts. Let's learn them all together, and that assists students, especially with memory problems, in terms of learning and understanding those facts and the relationship between those numbers. So spending time allowing them to understand that bond between three numbers does also help remediate. Number lines are another great intervention for students to use, counting on, counting backwards, skip counting, in order to help them really understand the numbers that they are working with. Compensation for subtraction is another great strategy. So lots of students have difficulty, especially with subtracting across 0. It's like you've never taught them how to subtract, and you give them a bunch of zeros and they don't know what to do with it anymore. So compensation allows you to alter those numbers, move them up or down in the direction that suits best, to provide a problem that is a little bit easier to solve, maybe using less renaming. And so we like to show students who are struggling with the renaming process the idea of compensation for subtraction to assist with this. A great way to introduce this compensation for subtraction is using a number line. Looking at a number line, putting, let's say we're doing 7 minus 3, for example. So I put my one finger on 7, my other finger on 3, and I see the difference between those two numbers. Well, now, if I move my two numbers up or down in the same direction, the same number of spots on the number line, we see that the difference doesn't change. And so if we do the same for compensation with subtraction, we're allowed to give ourselves an easier problem to work with, but still come up with the same difference. Area model we discussed a little bit, and that is just another strategy for solving multiplication problems. Partial quotient is a great way for solving long division problems, and that allows students to see clearly the partial quotient within a problem, breaking down, subtracting, and dividing again with maybe numbers working with straight 100 or straight 10, so that they can come up with the solution a little bit easier. Pattern blocks are another great intervention, and paper strips. When it comes to a variety of different strategies, fractions, we look at pattern blocks and paper strips for multiplication, division, other great topics to use pattern blocks and paper strips with. Visual models for fractions are also another great resource, and that is being able to add and subtract fractions with unlike denominators. So creating a visual model to add and subtract these fractions, which shows both, allows for both understanding and allows to help them solve the problem. And then model drawing, whether you have utilized the model drawing program or not, this provides us with a step-by-step set of tasks to complete when given a word problem, a story problem, to create a model that is always set up about the same way in order to see more simplistic computation. So if the first thing we do is we read our problem, then we look at who and what the problem is talking about. We determine what we call unit bars, and those are the models that we draw. We include our information and we break apart our models as needed. We fill in a question mark, and that's key because a lot of times students see a word problem and what do? They number pull, and that's the flaw in the thinking right there. You know, if you break it down, you give them the calculation of the problem, they can do it, but they're not coming up with the correct problem when it comes to the modeling. Then we solve and we put our answer in a sentence. So that is essentially the modeling process. So that was a lot that we just covered in a very quick 30 minutes. I am going to pass this back to Faulkner.
Thanks, Sandra. I hope everybody enjoyed the presentation. I'm just going to take a minute and let everybody submit any questions they might have for Sandra on that questions window on their screen. While we're doing that, in the meantime, I'd like to thank you all, or as a thank you for attending today's webinar, we would like to offer you a 10% discount off SDE PD events or on-site training by using the promo code W060717, so today's date with the W in front of it, before July 7th of this year. You might be interested in saving 10% and joining us at one of the summer conferences. You can join hundreds of other educators at the Reading, Writing, Math, and More conference in New Orleans, June 28th through 30th. 3 days of nonstop learning and inspiration brought to you by a team of pre-K through 5 experts. And there's also just a little tiny thing called the 2017 National Conference in Las Vegas. That's July 10th through 14th this summer, with 6 strands covering pre-K, K, first, second, DI, and teaching math. It's all presented by experts in the field, and it's really one of the largest PD events for educators in the country, with thousands of attendees and an experience you won't forget. You can learn more about that conference at sde.com/national. And of course, if you can't make it to a seminar or conference, SDE is always ready to provide customized on-site or web-based training that meets your school or district's unique needs. For any information about PD events, training, or resources, give us a call at 877-388-2054 or visit us at sde.com. And we do encourage you to follow us on social media, Facebook, Twitter, and Pinterest under the username SDE4Educators with the number 4. And it looks like everybody has gotten as much information as they can fit in their brains today, Sandra. So it looks like we're all set with questions. I would like to thank everybody for joining us today. We do appreciate it as we get towards the end of the year. I know it's more and more difficult to join us for these, so I do appreciate it again. And I'd like to thank Sandra, and I hope everybody has a great rest of the day and rest of the school year. Thanks, everybody. Bye-bye.
Thank you.